Hello, this is Dr. Mears. Today we are going to be learning about correlation and calculating the regression line by hand. So this is the sheet I gave you for class notes with some steps here, and this is the example that I gave you that can be found also in our book on page 230. For those of you who don't have the book. This is about a store, a pet store, and it's the time in weeks, 3, 5, 6, 9, 11, 13, and the number of mice sold at the end of those weeks, 41, 57, 61, 73, 80, and 91. And so what we want to do is we want to first find R by hand and then comment on R. If R is moderate strong to very strong, proceed to step 3. 3 is to calculate the regression line by hand. We're going to be using the formula. Comment on the slope and y-intercept of the equation, and then make a prediction and compare to your actual data point. So here we go. First, calculating R by hand, what we have to do is go and take out the table. So last lesson, we went through and we learned how to calculate using two variable stats, the n, which is the number of data points. There's 6, 1, 2, 3, 4, 5, and the last one is 6. The mean of x, which is taking these and adding them up, dividing by 6. And then the mean of y, taking the y values, adding up and dividing by 6. Again, that can be done on the calculator. That is fine. Then we had to fill out the table. We had to take our values and the mean of those values and subtract it. Then we had to square each of these, and be careful because you are squaring the negative, so this column should all be positive. Then this column we had to sum, so we had to sum up x minus x bar quantity squared. We got 72.84. You had to do the same process for the y's. Here's the y values, here's the mean, subtract, and then square. Again, these should be all positive. Add this column up, and you should get the sum of y minus y bar quantity squared. And then for the last column, please be careful. This is multiplication. We are multiplying x minus x bar, and I like to do a little star over this sometimes to remind myself. You need to multiply that times y minus y bar, which is that one. So multiplying those two columns, you're going to get this one. Add those all up, and it's okay if this one's negative. That's absolutely fine. That's where we actually get our direction, whether positive or negative, that's where it comes from. So negatives are fine here, and even if you get a negative sum. But this one is not. It is 337.16. I kept everything to 2 decimal points. It keeps everything consistent. So we all get the same numbers, because if you round too much, we will have a large round-off error. Okay, so doing that, we then have to find the R. So you take out your nice R formula, S sub xy divided by S sub x times S sub y. Those numbers come from these formulas, so you have to go back to that page and put in your summation of x minus x bar, y minus y bar, divided by the number of observations, 6. We get 56.19. That's the number that goes on top. Then we have to go back and we have to take the summation of x minus x bar quantity squared divided by 6. Please do that step first, and then don't forget to take the square root. 3.48 goes here, 3.48. Then we go back to that sheet. We take that sum of y minus y bar quantity squared, divide it. Please again do this in that one step here. Then don't forget to take the square root, 16.29, and that comes up here. So here are those 3 numbers. Multiply the bottom and then divide, please. Keep it simple. Do one step at a time. We come out with an R of 0.991. So I'm just going to write that down. RR equals 0.991. And so that was calculating it by hand. That was the first one. Number 2, we're going to go with a strong positive. Actually, let's go with very strong because it is very strong. Sorry for the erase. So very strong, positive, linear correlation. And let's tell why. Since R equals 0.991 and is close to positive 1, this proves strong positive correlation. I always like to prove it, and so that's the proving sentence right there. Because it's close to positive 1, that proves the strength and that proves the direction. Okay, so we are on number 3. Number 3 says to use this formula to calculate the least squares regression line. So our formula is y minus y bar equals s sub xy. We have that from the correlation sheet, all divided by the standard deviation of x squared times x minus x bar. So let's find these numbers and substitute them in. This y stays, that's our variable, minus our mean of y. Take this sheet back out. Mean of y is 67.17. 67.17 equals s sub xy. We're going to go back to our sheet. It's right here, this number, 56.19. 56.19 divided by the standard deviation of x. Standard deviation of x, which is 3.48. So 3.48, we have to square that. And then x minus x bar, which from our sheet, I believe is 7.83. Yep, 7.83. 7.83. We're not finished yet because we need this in y equals ax plus b, meaning we need to solve for y. So there's some math that we need to do. The first thing that you can do in your calculator directly is going to be 56, wrong screen. Okay, here we go. 56.19 divided by 3.48 squared. And notice the calculator will do this all in one. So it's 4.64. I'm keeping it to 2 decimals. So y minus 67.17 equals 4.64 times the quantity x minus 7.83. We have to now break out our algebra 1 hats. We're going to need to distribute this, meaning we need to get rid of the parentheses, and how we do that is we multiply the 4.64 by both what's inside the parentheses, x, and that minus 7.83. So y minus 67.17 equals 4.64x minus 36.38. We have to undo this minus by doing our inverse operations, which is addition. So we're going to add 67.17. We're going to come over here to its like term because it does not have a variable next to it. We're going to bring down the y. We are going to bring down the equal sign. 4.64x, and this is going to be plus 30.79. This is your equation for your regression line. That is how to do it by hand. Now, if you would like to check with the calculator, in your calculator, you have to make sure that your x values are in L1, your y values are in L2. You press Stat, and you want to calculate. You want to calculate the linear regression line, which is number 4, ax plus b. So we're going to do lin reg of ax plus b. You need to tell it where your data is, so L1, L2. What comes up is y equals ax plus b. Here's your a, your b, your r squared, and your r. Look at that, 0.989. If that's rounded, we did pretty good with our calculation of 0.99 by hand. So that's excellent. We need the two values, a, which they received 4.63 rounded. We received 4.64. That's awesome. For their b, they received 30.90. We received 30.79. That's fine as well. The reason why this is a little bit lower is because of round-off error, but it is very close, and I'm going to accept it. That is awesome, especially if you've shown your work with all of the tables. So since we calculated the linear regression line, our next step is going to be to comment on the slope and the y-intercept of the equation. So let's do that. I'm just going to turn to the back because I'm going to write a sentence for you. So y equals 4.64, I believe it was. 4.64x plus 30.79. So this is important for your IA. The slope is the number that is linked to x by multiplication. The y-intercept is going to be the number that is being added or subtracted. Now my sentence for slope is going to be, remember what slope is, it's the change in y, delta y, that is the Greek letter for change, divided by the change in x. So it's the change in number of mice divided by the change in number of weeks. So if we were to make 4.64 into a fraction, we would put it over 1. So 4.64 is going to represent the number of mice that's changing. It is positive. So we're going to get, let's see, 4.64 mice will be sold Sorry, 4.64 mice will be sold each. An increase of 4.6 mice will be sold every week. So it's going to increase every week by selling 4.64. Now I know we can't sell 0.64 mice. Let's not round to 4 or 5, but let's just be precise here with the numbers. So an increase of 4.64 mice will be sold every week. The y-intercept is going to be 30.79. And what the y-intercept is when x is 0. So when weeks are 0, this is how many mice are going to be sold. So at week 0, or no weeks that have gone by, 30.79 mice will be sold. Those are your sentences. And one more thing, we have to take our equation and make a prediction. There's the bell. Now everyone's going to hear it in the video. Isn't that awesome? So in order to make a prediction, I want to put in a week. So let's try x equals 6 because that is in our, so this is 6 weeks. So 4.64 times 6, you just insert it for x. And then this is multiplication, then addition. So let's see what we get. 4.64 times 6 plus 30.79. So our number of mice is 58.63. So let's check to see at week 6 what the actual data says. So we got about 59. So let's see what the actual data said. The actual data said 61. So we're pretty close. We said about 59, which is higher than week 5. Week 5 is at 57. So our prediction using our line of 6, we got 58.63. That's pretty close to 61. I would actually like to subtract that, but those are called residuals, and that's another lesson for another day. This is Dr. Meir. Sorry about that bell. This has been correlation and calculating the regression line by hand. Hope it helped.